So in this video, I want to explain some of the common nodes that I use in materials. These are in no particular orders that I placed, but these are the most commonly used. Even though there are so many nodes in here, I haven't really seen other people use that much. And these are like something that are available in like every single material that you will find. So I'll explain in detail. I've already created a video called Shader VFX Fundamentals where I explain some of the techniques and fundamentals, but I'll explain some of the stuff again in this video. Before we start, we actually need to know some of the basics for it. So let me go onto my website. You could actually go onto this site and get some like free textures and all. So let's say if I select this one and paste it, okay, or maybe you know what, let's just create around here like this. Okay, so before this, let me show you something. So when you create a gradient, this is like black to white gradient. Okay, so I'm going to make a gradient go left to right like this. Okay, now what this basically means in here is wherever there is black is 0 and wherever there is white is 1. So when you see a texture like this, it's nothing but a texture which has values 0 and 1 at different pixel locations. Like around here, you could see it's 0, 1, and in center it would be 0.5, and here would be 0.2, 0.9 like this. And you can even confirm it by going into the this section, what you call a color picker. And if I select this one, you could see this B value, this considers, you could see it goes a bit up. So around here it's 56, which is 0.56. Here it's 0.98, this is 100. So you could already see that wherever there is 0, it's black, wherever there is white, it's 1, and these are like all different ones. And a texture, black and white texture, is nothing but a texture which has values 0 and 1 at different location. And you can even confirm it by going like this. You could see this B value 21, that's 0.2. This, if I go in here, it said it is 0.91 like this. So this is nothing but a texture with different values. So if you go into your any material, you'll find that we have some values. So this is like only one float, only one float, only one float. There are 3 floats in here because 3 values, 3 floats in here, 1 float. And what this means is that this values usually, the roughness is usually from 0 to 1. Okay, so it doesn't go above 1 and the lowest is 0. So when you add a texture in here, like a texture in here, any texture, something like this. So when we use a texture in here, if I let's say add it in the roughness, what would happen is it's not visible much, but you could kind of see the difference. Maybe I have to be in higher quality for better. Let me see. I don't know, you can kind of see the difference around here. And I'll make the specular one. That would make it easy. You could see. And what this basically means is that wherever there is this point, I'm adding this value. Wherever there is this point, I'm adding this value. So instead of just giving it one single value, which is 0, which makes it completely rough, or sorry, no roughness everywhere. If you do 1, it makes it fully rough everywhere. We put a we use a texture in there, which basically gives us this values where wherever there is 0, it gives us 0 there. Wherever there is 1, it will give us 1 there, and all that stuff. Okay. And you would also see that I actually use the R channel. But if you use RGB, which are like 3 values, okay, R, G, and B, then it will only use the R channel because roughness is only float 1, which is only 1 value. And a quick explanation about floats would be if you press 1 and do left click, you get this one, 2 plus click, 3 plus click, 4 plus click, you get different floats. So we get float 1, which is just 1 value. Then we get float 2 or vector 2, like 2 values, float 3 or vector 3, 3 values, which can also be used as a color because color is nothing but 3 values like this, R, G, and B. And this is float 4, which is again 4 values, 1, 2, 3, 4, which is R, G, B, and alpha. So if you want to use, RGBA, and then you want to use just one channel, which is R value, which is like this value, you could use this pin, you could use this pin for G, B, and A. And if you want only just 3 of them, then RGB, because you could see there's no A, and there's RGBA, which means all 4 values. So again, float ones are nothing but simple numbers like 0.1, 0.2 or 11 or anything. Float 2s are basically like 0.1 comma 0.2, so two values, or like 0.1 comma 11 like this. Float 3 would basically be 0.11 comma 11 13 like this, or whatever. Okay, 3 and 4 would just have 4 of them. Now one important math you need to understand regarding these floats is that you can add to float 2 with float 2. You cannot add float 3 and float 3. So if I try to add, I'll explain what add does. If I try to like add it in here, you'll get an error. Like arithmetic between float 2 and float 3 are undefined. You cannot add, multiply, or do any arithmetic function between 2 and 3 like this. But it has to be both same, so both of them should be same. But you could also use float 1 and do addition or any arithmetic with any other floats. So you could see it works. What this basically does is that if I add 3 in here, it would add 3 on x and add 3 on y. So if I do 1 2, this would basically give me 1 plus 3, which is 4, and 2 plus 3 5. So it would give us 4 comma 5 when you use 1. But if you use 2 like this and do, let's say, 2 2, or let's do 2 3, it will give me 3, 2 plus 3 5, so 3 5. So just keep that in mind, that you cannot do arithmetic between like floats except float 1. Like float 1 can be added to everything. One important thing you need to know about texture sample is, if you use a texture which is called pack texture, which I'll add a video on my channel called packing texture. If I use this texture called cloud texture, you would see that this is not black and white. But then if I try to use it in this channel, it would use just the R channel. Okay, and you could see some difference you would see in here. But why is that? Why is the black and white, even though this is not black and white, why is it working? And if I even show you something which is cool, you could see, maybe I add a color, maybe that would make it easy to see. Yeah, so you could see that this is how it looks, but if I use G, it changes the way, and if I use B, it changes the way. But how is that? Well, simply because a texture is nothing but 3 values with RGB. So if I use just R channel, this is what it is. If I use G channel, this is the texture, and this is B texture. What this means is that if you want to use 4 black and white textures, instead of creating 4 different textures, you could just create one texture and then add it in one. Like one single image which would have all these textures, and then you simply need to just use the correct channels. Okay, and I have a video on how to create pack textures like this. So this node is the new one, color ramp, and this color ramp actually is going from 1 to 0. So if you turn this to like this, then this one would basically give you the same texture. So if you use a texture in here, let me do the R channel, which is going to be, this texture. If I add it to the base color, you would see that there is no difference in here. Okay, because this is 0 to 1. Now I have a video on color mapping, so I'm not going to go into color mapping, but this basically allows you to color the texture, like this type of textures, black and white, with your own color. So wherever there is 0 right now, which is black, is set to 0. Wherever there is white is set to 1, which is white, and set to 1. So no changes right now. But if you change this into something, let's say pink, then wherever there was 0, which is black, turn to this pink color, and wherever there was, let's say this is 0.2, okay, then wherever there's 0.2 is this color, wherever there's 0.5 is this color, and wherever there's 1 is white color. But if you turn this into blue, you turn this you just map. Okay, this is called mapping. You're basically just changing the 0 to 1 values in this texture into this colors. Okay, and if you add more, you could actually do something like this and then play around with it until you find something that works with your texture. This is called gradient mapping. I have video on my channel, but this is what color ramp does. It is available in 5.6 and above, Unreal Engine 5.6, and you would see this one. I used it in this texture, or in this effect, sun or lava. I already have a video on my YouTube channel on how to make this sun lava orb. You could check that. So now that we have learned some basic, let's start with the arithmetics. Okay, so add is very basic. If I do add in here, I add to my base color, Again, 0 plus 1 is obviously going to give us 1, so it's white. If I do 0.5, it's going to be 0.5 value. So what we can do is we can take two textures, and you know what, this one I'll also not take new texture. I will use a radiant exponential so that it's easy to understand. Radiant exponential is nothing but, you can see it's just a sphere like this. I'll make the specular 0 so that we see it like properly, and maybe even add it in emissive. I'll just make this into an emissive material, okay? That way I don't have to worry about like specular and stuff. So you could see that this is how this looks. Now, just as I said before, wherever there is black is 0, wherever there is fully white is 1, and wherever there are like grayish value and all, it could be like middle values and anything. So closer to white values would look white, and closer to black values would look like darker or blacker. And you could already tell this is white, this is 0, and these are like fading out, so like different numbers. And then we have our texture. I'll just use my noise 1 texture because then you guys don't have to see this. All of these textures are available on my website, okay? So this is the texture that I have right now, you could see. Now if I take this and add my exponential, you could see this is what happened. So I hope you guys understood what happened. Basically, wherever there was 0 and 1 values, so remember this was 0, this was 1 and all, and then in here this was like very different, like it's just filled with different values, zeros and 1. Right now this one was 1, right? Like lots of it's what 1 and 0.5 or anything like in here because of gradient. We just basically added on top of it. So now the values in here are above 1, okay? And because it's an emissive channel can go above 1, so it's okay, but it just gets brighter based on how much emissive you used. But right now we just did was we added the 0 to 1 value in here, like in whatever it was. So every pixel got added with whatever the values were in here. I hope you guys are understanding. So let's assume that this is like 0.5, and let's assume this point is 1. So 0.5 plus 1, it turned to 1.5. Anything above 1 is going to look white. Now lots of the mathematics stuff, when you do, you sometimes don't want to have above 1 and below 0 values. So for that we use a node called Saturate. So if I add this, there's a Saturate node, and what Saturate node does is that any value in here which is lower than 0 would turn to 0. So if there was like negative 0.1, negative 0.5, it would just turn to 0, and anything that was above 1, which is 1.1, 1.2, 2, 3, whatever, it turns to 1. And we know that this value is going to be above 1 because of this, as this is 1, obviously if anything we add in here, then it will turn above 1. Then this is a way to actually clamp it so that it doesn't go above 1 and below 0. This is usually used when you are trying to do some kind of mathematics or use it in some different nodes. Really comes down to your preference. And then there is clamp node, which is same as Saturate, but except you can actually choose. So this one and this one would not look different right now because minimum set to 0, max is set to 1. But you can even make it like clamp to 0.5, 0.2. So you could see, we can see the difference. Anything above 0.2 was just clamped, and everything above 0.2 was turned to 0.2. If I do like 0.5, and you could even see this is how it looks. So clamp and saturate are common. Usually you would just use saturate because lots of the time you do 0 to 1 values. Let's do multiply. I'm going to take this and multiply, and you would see this is what happened. And again, I don't think I need to explain it anymore, but anything multiplied by 0 is going to be 0. Anything multiplied by 1 is going to give the same value, and anything multiplied around here, which is, let's assume this is like 0.5, it is going to go like this, like 0.1, 0.2, 0.3, 0.4, 0.5, like this, and then basically be 1 for a specific area based on like the density and stuff. Anything multiplied by 0 is going to give us 0. And what is 0? Black. Anything that is multiplied by 1 is going to give us same value, which means that whatever the texture is in here is going to give us perfectly that texture. Usually we use multiply when we want to do masking. So sometimes when we don't want to show some of the area, one example I can show you guys is in here, where I did some masking to kind of make it look like it's flowing like this. The next thing we will learn is divide. Now I haven't really used this much on like textures like this. So if we do 1 divided by 2, which comes down to 0.5, we'll get 0.5. 1 divided by 3, 0.33, and like that. 1 divided by 1 would give us obviously 1, which is white. But what would happen if I do to 0? So in math we cannot really divide by 0. I think it's infinity in math when we divide by 0, but here we just get black. If you do, let's say, 2 different texture, you get this stuff. Now I don't really understand how the divide works when we do with materials, because again it's like I've never used it, to be honest. So again, this is just what we are getting basically, and I don't know what to do. Okay, so I'll not explain divide much. You also get like something like this. So let's just go with the next one, which is subtract, which I use like quite often. So subtract, multiply, and add are like the most commonly what I've used. Again, it's same. We are going to, take the point from this value and then minus the value from whatever the point is at that location for like this one. So again, subtraction is, again, you could understand it, but this is usually what we use for corrosion and all that stuff. Like when we want to dissolve something, or like instead of just feeding out, we just do dissolve or corrosion like that, then we use subtract. And again, it is same. We are going to take 1 point from it and then subtract the same location at that pixel location when we use like 2 textures. So if I use, if I use this R channel, then this is, let's say this is like 1 around here. And then if I add this, then this point would be 1, because this is like 1, right? So white completely. So if I take this and subtract this one, we get like black in here. Why? Because we are minusing 1. Remember, this is 1, this is 0, this is 1, and the values keep increasing slightly from here like this. So anything minus 1. So if this texture is just in 0 to 1 value, so the highest value in here is 1. So obviously if we minus something 1 completely, we get 0, or actually negative values, which is black. So we get like this nice, instead of completely circle. So if you do multiply, we get like completely circle, right? Like completely same as this mask. But when we do subtract, we get some nice cuts like this. You could see, because what we are doing is we are just minusing this value. So we are minusing 0 from here, which is why this looks the same. But if you check around here, we are doing minus of 0.1, 0.2, and all that stuff, and here's 1. So obviously this would turn to black. But depending on what the texture is around here and what is used around here, it would look different, which is why it looks like this. And unlike multiplication addition, which basically works the same, like a plus b is equal to b plus a, or a multiplied by b is equal to b multiplied by a, this one is different. A minus b is not equal to b minus a, right? Because 2 minus 1 is not equal to 1 minus 2. So right now, if I just change the order, we get something like this. And a quick shortcut, what we usually do is, if I, let's say, do 0.2, we get something like this. You could see, pretty cool effect. So I'll explain what power does. And right now, if I take the power, well, I have to search power. What this does is, it's basically multiplication of the same texture on itself. So for example, if I take a value called 1 and then I add it in here, this is just going to give me 1. Why? 1, it is 2 exponential. What it means is that I'm doing 1 multiplied by 1. If I do 3 multiplied by 3, like 2 times, is going to give us 9. If I do 10, then it's 3 multiplied by 3 multiplied by 3, like 10 times like this. Again, if you have done basic school maths, it is like this. So 2 to the power of 3, which is like base, and then this is exponential. It would be 2 multiplied by 2 multiplied by 2, which is 2 to the 4, 4 to the 8. Same with like 5. If you do 5, 4, that's 5, 5 multiplied by 5 multiplied by 5. Then it would be obviously 5 5 are 25, 25 5 is 125. So 125 times 5 is 625. And you could even check like this. 5 times 5 times 5 times 5 times 5, like 625. So that's basically what this is, it's multiplication of the base with itself, but how many times you want to do it. Now, why is this important? Why is this node important? Well, this has like a very cool feature or tech thing that it, like, it's I guess it's personality, I don't know what to say it. But what this basically means is that if I connect this as the base, so my exponential, which is this, what is it, like this radial exponential, if I connect it in here, if I do 1, it's just going to be nothing. If you do 0, anything exponential to 0 is 1. So if you use 1, it's same. So like 5 exponential 1 is 5, 10 exponential 1 is 10, because we are just saying that there's only 1. But if you do 0, it's 5 exponential 0 is 1, 10 exponential 0 is 1. So every time that you use 0, it's just going to give you 1, which is why you could say it's white. And 1 is basically like no change. But if you do 2, you would see something happen. It reduced it. If I do 5, it reduced it. Now the crazy part about this power node is that it is used for contrast, because what it does is that it like decreases the lower values like a lot, but the higher values not that much. And what I mean by that is, if I again go in here and let's take, from 0 to 1, because usually we use it for textures, right? So 0 to 1. So a texture is nothing but 0 to 1 values, just like we have said before, like all points are different values. The thing about it is power is that if you take something like 0.2, okay, a value called 0.2, which is going to look something like this, okay. So if I do 20, this is how the 0.2 is going to look. If you like exponential it by 3, so if we take 0.2 exponential 3, which is 0.2 multiplied by 0.2 multiplied by 0.2, it gives us 0.008, which is like fully almost black, but it's like from your eyes it's just going to look black. Technically the value is 0.008, but for you it's just going to look black. And if you take some middle values, which is like 0.5 and do cube, so let's do 0.5 cube, 0.5 cube, which is exponential 3, we get 0.125. But if we go for some higher values like 0.8, and let's even do like 0.9, let's try both, okay. So if we take something like 0.8 to cube, we get 0.512. So it didn't decrease that much, 512. And if we took 0.9 exponential 3, we get 0.729. So you could see what I'm getting at. Like the higher the values, the difference is not that much. And one way I can show you is by this graph. It's not complicated, so don't get scared by a graph. I also was a bit scared, but if I do, let's say x is to k, and then I add k, why is there no graph? So if I take x raised to k, okay, so again, just don't get scared, but you could see only check this much part, okay. So let's do this much, because we only are going to check from 0 to 1, because that's our texture, right? 0 to 1 value, and k is 1 right now. So when k is 1, any value which is 0.2 is going to give us 0.2. Any value which is 0.4 is going to give us 0.4, because 0.4 exponential 1 is 0.4, 0.6 exponential 1 is 0.6, which basically means no change. So you could see that this is obviously a linear line. But what would happen if I turn the k, which is exponential, a bit up, which is 2? So what right now happening is, wherever there is 0.2, like 0.2 raised to 2 is this point, whatever this value is. So if we go down, this is the value. And you could see suddenly it's not a linear graph. You could see it is actually a bit like this curve, which means that lower values are being at the lowest values a lot more. If I do 3, which is what we did before in our math, right, which is 3, 3, 3, you would see that till this point it's almost black. But as we go up around 1, it still stays white, like not much difference, to be honest, around here. So this creates contrast where it intensifies the black area, but not white that much. So like the black area gets more darker, but white also gets lower, but not that much, you could see. And as we go forward, we can create nice contrast like this. And you could even see this happening here, which is, if I keep increasing it, it is going to increase the black area because we are just increasing the contrast. So just keep in mind that power is nothing but multiplying it itself. So when you use 3, it's also you could also do this by multiply this and then multiply this. So this and this is going to look the same, you could see, but obviously we don't want to create multiply when we want to do 100 times or something like this. So I hope you understand. And power node I use like quite often, like especially on these orbs, like all of these orbs I've used power node to control the Fresnel, like this edge glow. So other nodes I'm not going to go in much details because these are like very basic, easily understandable, so I don't have to do much math and all. But again, texture coordinate, you could get it by pressing U and doing left click. This is just UV. So if you do U and do left click, we get UVs, basically texture coordinate, which goes into this one. UVs are basically two values, right? It's float 2. There are U and V. So it's 1, 1 right now. And if you add it in here, we basically get our texture. And because it's UVs, I can multiply this by 2, and then it shows the same texture twice on all 4 quadrants. So 1, 2, 3, 4. You could see I change it to like this icon, and if I do 2, it's this way. 3 is this way. If I do 0.5, it's showing like the top quadrant like this. And again, this is UV, right? So when you are doing 2, we are actually multiplying, and we are turning this 1, 1 into 2, 2. Okay. Again, if you want to learn more about like the UVs and stuff, this video is like a lot more better, because this one I want to keep it about material nodes. But if you want to understand UVs and stuff, like all these basics of UVs, like 0, 0, 1, 0, and how we are multiplying and all that stuff, please watch this video. But for now, I'm just going to keep it a quick like this. But this is basically used for tiling of the texture. Now another thing is, this is UVs, right? So 2 values, 2 floats, but we only have option of adding one of it. What if I want it to be, not multiplied or tiled in the same way, like not multiplied like completely like all 2 direction equally? What I could do is I could take a 2 vector, add around here, multiply around here. Now you could see we get black because 0 multiplied by 0 is going to give us 0. If we do 1, it's going to look same. But if I do 2, you would see we are now tiling on U 2 times, but Y only once. If we do 2, this is same as typing 2 and giving it in here. But when we use 2 vector or 2 float, we get option to control it. So this is very important when it comes to like this nodes and stuff. You need to know how many values are there. So for example, for this there are two nodes, right, or 2 floats, sorry, which means that you know that we can control both of these values separately. Same as, if you use a texture and you use this pin, which is like RGB, or sorry, this is like float 3, right? Then we get 3 values, and you could obviously multiply it with three of them like this, another 3 value, and then basically let's do 10 and 20. So this one would basically give us 30, 0, 0 like this. So just knowing this helps a lot in maths, knowing how many floats are in there. Now usually you would not use 2 like this float in here. What you would actually use is you would use 2 single floats, so float 1, float 2, and what you would do is you will use append. So we have 2 of them. One is append vector, and what this basically does is that it takes 2 points, so 0, 0, and it will just turn this into 0, 0. So nothing crazy. So it will basically turn it into this. So we take 2 of them and this one. And the reason why we do this is because we cannot convert this into parameter, because it simply turns it into 3 parameters. So usually we use, S. If you press S, you could use a scalar parameter, or just convert this to parameter. This is for material instance, but I'm not going to go into that detail right now. It's very basic, first thing you learn. And if you add it in here, you could see that if I type 1, 1, we get this one. If you do 2, we get this way. And there is also append many. This is a material function. So if I double click on it, because you could see it's blue in color, it opens this one, and you could see this is just using append, append, append. So this one basically would allow you to use, like this, like 4 different values in here, 4 different values like this, and then get, all 4, like 2 comma 0 comma 0 comma 1, like this. From here, if you just want only 3, so 2 comma 0 comma 0. Here only want the first 2 comma 0. Usually you would not use this if you want to just do, 2 of them, because if you check in here, it's using 1 2 3. So obviously for optimization purposes, why would you use it if you are not going to use 4 values? This is only good if you're going to use, 3 values or 4 values. But if you're just going to use 2, just use the basic one. Now here's another thing that you need to understand is this mask node. This is also very common, component mask. And what this basically does is that it allows you to just get some of the values instead of, all. So for example, in here I have 2 of them, right? So this one would give us same, because you could see it is taking the first value and second value. You don't have to worry if it says RGBA or UV, XYZ or anything, doesn't matter. What matters is what float value you get or what value you get. All of them are same, like RGB, XYZ, UV. It's just naming conventions, but all of them give like float values. So what this gives is, if you check just our channel and let's connect it in here, we get this stuff. So if you connect it directly, you get all these colors, because right now it's 2 colors, right? Like RNG or X, Y, U and V, or whatever you want to call it. This is 0 0. This is 1 1, 0 0 1 1. If you go in here, it would be 1 0. Here it would be 0 1. A quick explanation would be in this video. So 0 0 1 0 1 1 0 1. This is UV's basic 1:1 UV. So if you take like Blender or any software, you could see whenever you try to do some UV mapping like this, let's take a cube. Whenever you try to do like a UV mapping, we get like this square, and this is nothing but the basic UV one, like 0 0. This again, some softwares like use it in a different orientation, but in Unreal Engine it is like 0 0 1 1. So it would be 0 0 1 1. This one would be 1 0. This one would be 0 1. Why? X and Y. This is like basic X and Y coordinates, okay? This is X axis, this is Y axis. Again, watch this video to get in, explaining in much more detail. And what would happen if I do masking of R channel, which is the first channel, which is UV, okay? We will get 0, like the first channel. We are masking only R channel. So this one we are not even taking, like the V channel we are not even taking. So it will be 0 around here, 0 around here. And this one would be 1 1. So it starts from 0 goes to 1, 0 goes to 1, which means we get a gradient 0 to 1. What would happen if I take the V channel, UV, so second channel? You could see we get 0 1. Where is the video? You could see we take the second one, which is 0 0, and we go 1 1. So 0 to 1. That way we get gradient. And if you use the node called linear gradient, you could see it's blue in color. So if I double click on it, this is what we get. We get the texture coordinate, masking of R, masking of G. So this is quite commonly used when we want to do, some sort of effects on only one of the node. So lots of the time what we would be doing, you would see, is that we will take this. So we will take R channel. So this was R channel, G channel, because we are just separating it. So we are separating the U, we are separating the V. And then if I want to do some of the mathematics on just this one, so if I want to do some kind of addition in here, addition is like very basic, but sometimes we will use, some kind of effects that we only want to do for the U channel. Then we do something like this, and at the end we do make float to, make vector to, like this. Or you could use append, like I said, because it can convert it back to what it was. So again, what we did was we separated this into 2 different points. So first float value, second float value, and at the end we are just adding it back together. So sometimes if I want to just do something to the R channel, I can do some stuff here, and at the end append it again, like this. Another node is this make vector to. This is again, you could see it's same. And you could obviously turn this into vector 3. This is like weird, I don't know, but make vector 2. This used to look different in the past, but they change how it looks. So you could also use this, it's same append kind of stuff, but with more option. Another thing I want to show you guys is this node called break, but now you could say it's not showing anything. I don't know why they did it this way, but if you click on this node and search, it doesn't show. But if you right click and do, you can see like break float 2. Again, this is going to do the same. It's going to give the R channel. This is going to give the G channel. R channel, G channel. You could see. And just like that, we have break float 3. Obviously, if you use this in here, the B channel is going to be empty. Okay, because these are only U and V's, right? But if you use, some kind of stuff like RGB, like this, we will get separate values like this. Same like that, we have make vector. So I don't know why they said break float, but then they say make vector instead of make float or something. And you could also make stuff like this. Okay, so these are common nodes. So let's take this texture, let's add it in here. Let's add our RGB. And what would happen instead of multiply if we did add? Right now, something did happen, but you cannot tell the difference because we did add 1, but the texture repeats every 1 point, I would say. So this is what I want to show, like a texture is basically repeating texture. So again, if you check this texture, we have like shared wrap, shared clamp. By default, it is using wrap like this one. What this basically means is that the texture is repeating. So you could see that this is UVs, right? So this is where by default it shows our texture on a plane. So if we do 0, this is how the texture looks on a plane, okay? Because this is 0, 0, this is 1, 0, 1, 1, 0, 1. And what's actually happening is the texture is actually repeated every single direction like this. But we are saying that, hey, only show me this much area. So when we do multiply, we actually turn this into 0, 0, 2, 0, 0, 2, 2, 2. You could even see in here, which is why it shows 4 of this. I'm not going to go in much detail, it explains in here. But when we do addition, we basically are adding 0.5. When we use addition 1, right, then we turn this into 1, 1, 2, 0, 0, 2 and 2, 2, which basically moves it around here. Actually, it moves it around here like this, because we are adding it this way, adding 1 in every single direction. So when we do 1, it did do something, but because the texture is repeating, it looks the same. But if you use something called a time node, now to show you what time node is, if I use debug scalar values, add it in here, you would say this is what time is. It's just a node which basically gives a constant float which increases like this. So if I add this in here, we get this stuff. You could see the texture is moving and you could see the difference, okay? So if I do 0.5, you would see that it actually moved in this direction. You could see we moved it this much area, 0.5. I don't know if I've shown anywhere. Yeah, like this. So time is basically used for, panning or adding some sort of float or to do some sort of effects which require kind of animation. Anything that has animation would require time node, okay? There are some different methods too, like dynamic float and all, but usually time node is what we use. Or sorry, dynamic parameters, which we use in Niagara system, which I've explained in this videos, but for now, let's just go in here like this. Now, remember, if I do append, if I do, append many, or append vector, sorry, and then give this as 0, we are only moving on the left direction, because at the Y direction and the V, we are doing nothing, but we are doing only on X direction. So just keep that in mind, that time is just a float value that we constantly add. And with texture coordinate, we can do lots of stuff like addition, multiplication for tiling. Addition basically also allows you to create some distortion too. So you could see some distortion. I'm not going to go in much detail, but basically instead of adding, one value everywhere, so instead of adding one float everywhere, a texture is different points like 0, 0.2, 0.3 and all that stuff. So at different pixels we are adding different stuff. And you could even do, you know, panner to create some wacky effects. But panner is nothing but the same stuff that we did, which is this takes UVs. The speed is basically x and y that I showed in by doing append, and time is basically time. So you could even go in here and then multiply this by a value like 2, and we don't need all of this, and it will basically do twice the speed of this. Okay, and speed is 2 floats, so 0 and 1. So if you want to create parameters, you will need to use 2 floats and append it. Okay, so just keep that in mind. Whenever you see 2 floats, you have to append it if you want to use a parameter or scalar like this. This is float 1, this is float 2 because coordinates. Then we have a rotator. Again, I'm not going to go in much detail regarding rotator. It's basically doing what it says. It rotates it. You could see if you do this, we can actually change the speed and all. Now we don't have a node to connect in here like this, so you need to take time and then basically multiply it. So you could keep the speed as 1 and then take a time node like this and multiply it, and then this would be your speed instead of doing it via this. So 0.2, 5 and all that stuff. Now let's learn about Lerp. Lerp is something that I use very commonly. Again, I'm not going in any particular order, so I'm just going in like whatever way I think would work. So right now I take actually let's just remove this. I take two colors by pressing 3 and doing left click. One is blue, one is green. If I take this into B channel, and you could see this A is by default 0, B is by default 1. So if I connect in here, what this means is that if I use 0, it's going to use this color. If I use 1, it's going to use this color. If I use 0.5, we are going to get mixture of both. If I do 0.1, we are going to be closer to this one like this. So again, this is float value, like float 1. What this means is that we can just take a texture which is nothing but values with float 1s. I can give it in here and we get different texture based on our different pattern or colors based on our texture, because each pixel has different float values. And sometimes you might need to make one of it like a bit darker so that the other is visible. It depends on texture. Okay, very much depends on the texture how this is going to look. So if I use my noise 4, my noise 3, you could see the way this looks is like way different. So Lerp is basically good when you want to do, you know, 2 different colors. And the best thing about Lerp is that you could keep stacking it, so you could add more of it like this and then add a different texture in here, something, let's say noise 1 like this, and we can keep adding more stuff on it like this. So what this means is that wherever there is like white, wait, A is what? A is black, sorry. So wherever there is black, we are going to use full of this texture, like this pattern. You could see. But wherever there is wherever there is white, we are going to use blue. So we can keep stacking it on top of each other. So we learned about all 4 of them. Time, I'll explain this later. We learned about saturate, clamp. Let's learn about OneMinus. So let's take UVs again. Let's mask it so that we only get black to white, like one gradient basically, like this. Now OneMinus X does exactly what it says. It does 1 minus whatever we provide from here. It's just going to reverse it. Let me show this. So when we do 1 minus 1, we get 0. 1 minus 0.5, we get 0.5. 1 minus 0, we get 1. So this basically reverses it. And you could see it reverses it. If we do some addition in here, before this, let's say if I do 0.2, you could see some different, it is not looking perfectly like, you could say it looks like this around here, but if you go in here, it looks different. Why? Well, simply because it is 1 minus x. Right now the values in here, if you do 0.3 addition in here, it will turn 0 plus 0.3. 0.5 plus 0.3, 1 plus 0.3. So the highest value here is 1.3. So 1 minus 1.3 would give us negative 0.3, which is around here like this. So keep that in mind when you use 1 minus x. It is not magically going to turn your black and white texture into white to black. It will only do it if your texture has 0 to 1 values. Else you need to, use saturate and all that stuff to clamp the values and all that. Next we have absolute. Absolute is nothing but it just takes the white, any negative value and turns it into positive value. So there would never be a negative value. So if I take this, which is 0 to 1, and add this in here, nothing's going to happen because there is no negative value. But let's say if we do a subtraction, so let's try doing 1 minus x. This would turn into this way, and let's do a subtraction. I don't know what this would give us. Okay, this gave us this stuff. So obviously some of the values are going to be below 1, which is why if you take this, you could say this is how it looks, and in here it's actually negative values. So if you take this one, which is 0, let's say 0, and this is 1, 0 minus 1 gives us minus 1, like this way. So when we do absolute around here, it turns this minus 1 into 1, minus 0.9 into 0.9, and all that stuff. And this is what we get, a nice beam like area in center. Then we have frac. Frac basically does is, if I showed you by doing debug scalar value, let's remove this, add this in emissive. If I, let's say, give this 0, it's showing me 0, but if I do 1, it's sorry, let's do 1.3, we get 0.3. If I do 10.5, we get 0.5. So what this basically does is that whatever is the left value, it just ignores it and only takes the decimal values. And what we could do is we could take our time node. Again, if I just connect time node directly, we can see that this is how it looks, but the right part goes from 0 to 9, 0.0 to 9. So if I take the frac node and add it in here, we get a value which goes from 0, 0.0 to 0.99, 0.0 to 0.999. And with this, let's see, if I take this, we get a weird flashing effect. It's not perfect, obviously, because it's going like way too fast. So what I'll do is I'll take my texture, I'll do subtract, add it in here. If I do 0.1, we are subtracting 0.1, so more black values appear, 0.3 like this. And if you, let's say, add time frac like this, we get an effect which goes like this, 0 to 0.9. So you could kind of create like flashy patterns or repeating patterns. Maybe lots of the time I've used it, to create some animations too with world position offset. Basically make it bounce, make the colors go, flashy, like close open, close open, close open, like that. So just keep that in mind, that frac node basically removes the like the left part of the decimal. Some quick effect I can show you is I took a texture coordinate, I masked it, which goes from 0 to 1, and then I multiplied by 10, because if this is like 0 to 1, right? So 0 to 1, so 0, 0.1, 0.2, 0.3, it's just going to do no difference because the frac is just going to give us 0.1, 0.2, 0.3. But if I multiply it by 10, so again this value basically turns into 0 multiplied by 10 is 0, 0.1 multiplied by 10 is 1, and all that stuff with all these values. And then if you do fractal, it only takes the right decimals, so we get like these patterns. I don't know, you could use it to create like roof patterns and all that stuff. There are lots of different stuff that you could do. I will be creating a video called like material techniques, like some of the material techniques that I want to show in future, like distortion, triangle shape, and all that stuff. So for that, I'll explain frac in there in a bit more detail on how to create rings and stuff. And then we have some gradient related stuff. I showed linear gradient. So I also showed radial gradient exponential. There's SphereMask too. Again, if you connect it in here, I don't know how it's supposed to do. So you're supposed to do like 1, I think, 0. I don't quite remember how to use this, but I think it's supposed to be something like this, 0.5. Yeah. So you take a texture coordinate, you do point this, and then was it 0.5? Yeah. And then this is the hardness, so you could control it. So again, SphereMask is basically radial exponential in different way. I don't know which is like better to use. You could even see that this is like vector 2, scalar, scalar. So this is a static bull. If you want to invert the density, so SB, so you would search for static bull and basically say that, hey, I want to invert the density. Center position is like where should the center be, so by default it's 0.5. You can hover on it and it says 0.5, which is in center. If you do 0 0, if you use 0 0 in here, so keep that in mind. This is, if you hover on it, it's vector 2. So if I connect it like this, it starts from here. If I do x1, then it starts from here. x11, it starts from here. Okay, so radius, density, invert density. I don't know why it's showing in bracket in here but not in here. So density and all that stuff. So again, just play around with it. It's one scalar parameter, or float one basically, like this. Okay. So let's check this step and SmoothStep now. I'm just going to use the linear gradient right now. We already know how to do with masking, okay? That is the same stuff that is added in here. If you take the U channel, which is texture coordinate in R channel, basically, if I take step node and add it into Y and add around here, you could see everything turned to white. But what if I do 0.5? Suddenly you would see that we get a harsh edge. Now why is that? Well, if I connect in here, we have 0 to 1. And what this does is that it takes a value which is, let's say, 0.5, which is going to be in center, and anything below it, it turns to black. And anything above it, it turns to white, like fully 0 and fully 1. So fully 0, fully 1. But below 0.5, it is turning into white, and below 1, above 0.5, it's turning into black. So it depends on where you add it. So if I turn it into 0.5 right now, if I add it in X, you would see this is what it does. So it allows you to create harsh lines, like no smooth in center like this, and basically just take harsh lines. If I do 0.2, so anything below 0.2 would turn to black, anything above 0.2 would turn to white, which is 1. So 0, 1. SmoothStep is similar, but except instead of it doing, harsher, it does it smoothly, like it doesn't remove the gradient. And one important thing, one mistake that I used to do is, if I take this U gradient and then I do SmoothStep, I would just add it and be like, why is it not working? Well, simply because it is added in minimum. It should be added in value. So whenever you drag a node like this, it adds in minimum. So just keep that in mind to add in value. And it is same. What this is doing is, from 0 to 1, it's just doing, it will do just SmoothStep. Okay. So if I do 0.5, anything above 0.5 turn to white. Okay, so from here it's just going to be white, but there is a gradient in here. If I turn this to 0.5 in here, so you could see 0.5, but there is a gradient still. So step node and SmoothStep node is same, but the difference is that smooth. Okay, so it keeps the gradient. Then we have a distance node. The distance node basically gives you value between 0 to 1 based on the distance from like A and B. So how much far it is. The way I have seen it used is if I take this UV, I take this at 0. Let's see. So this is what we get. So from 0, how much distance there is. If I do 1, so if you show UVs, this is how it is, like 0 0 1 1. So what this distance does is, I believe, I'm not 100% sure, but it basically checks how much the values difference are. So 0.5, so you could see that from 0.5, if you take this is 0.5, right? Because 0 to 1, so obviously this is 0.5, this is also 0.5. So how much distance it is from 0.5. Okay, so it's saying that, hey, this is equal to 0.5. So this is giving us 0. This is the furthest from it. If I do 0.8, this point is 0.8, and based on how much further it is from 0.8, it gives us black and white value. So again, if you just want, middle dot like this, you could you could just get it and then maybe do 1 minus x, you get something like this. And again, maybe I don't know why it's looking like this. So we will do power node and then basically increase the intensity and we get this spherical mask again. So there are two more nodes that I added around here which I totally forgot. Ceiling and floor. These are very simple. Ceiling and floor is nothing but, again, you could even search for like a round, I think, rounding up and all that stuff, rounds the value to the next whole number. So these three nodes are very simple, easy to explain. Ceiling basically does is that if it's 0.2, 0.3, it will just turn it into 1. If it's 1.3, it will just turn it into 2. 1.5, 2. 3.2 would turn to 4. I can even show you by just doing some result in here. Take a 1 value. 0.1 turns to 1. You could see 1.5 turns to 2. Okay. Let's just add it in all of this. Now, if you do floor, it does the complete opposite. So 1.5 turns to 1. 2.0 or 2.5 turns to 2. Rounding is different. 2.5 turns to 2. 2.6 turns to 3. 2.2 turns to 2. Okay, so again, these are also quite often used. One cool example that I can give you for this is if we take a linear gradient, okay, in the U channel, if I use these nodes, so I just copy pasted it quickly. I'll explain. Okay, and let's add it in here, and this value should be same. With floor, we can actually create like bands like this. So what I'm basically doing in here is we are taking 0 to 1 value, multiplying it by 5. So 0 times 5 is 0, 1 times 5 is 5, 0.1 times 5 is, this is going to be 0.2, right? So 0.2 times 5 is 1. So we get this stuff. So if I take, just this one, this is how it looks, right? But because it's turned to floor, any value which is like 1 point, let's say this is 1.1, 1.2, 1.3, everything turns to 1. So we get this nice band. So all of them turn to one color until it changes to next decimal. And then we do divide. So if I just use floor, it's not going to look perfect. It's just going to be like overexposed because multiply, right? So it's not 0 to 1 value. It's not wrong, anything wrong in here, but every value is still above 1 right now. So this is 5 because 0 to 1 multiplied by 5, this is 5. Floor is not going to do much, it's just going to keep it 5. But when we divide it again by 5, which is this one, everything turns to 0 to 1 values. So, and usually you try to keep the values in 0 to 1 so that we have more control after it, but nothing wrong with doing this way too. And you could say this is what we get. If we do ceiling, we get completely opposites. This is used like quite often, like if you use with time node, can create like timed stepped effect. So if you use something like ceiling with this one, and if I use debug scalar values, you would see we get the decimals don't count, and if we use floor, it would just take smaller values. So you could create some stepped effect like this. So instead of it smoothly going up, you can kind of make it be what you call like stop motion typey. So let's understand Fresnel. Fresnel I'm going to quickly explain, but I've used it in every single op that I've made around here, and all these tutorials are available on my channel. Now Fresnel looks nothing different in here, right? Because it's a plane. If I do some slight angle change, it does look different. But if I take a circle or sphere, you could see the difference. And Fresnel, it does nothing but if I take a mesh, if I check for the normals like this, what it does is that it checks which normal is facing you. So any normal which is facing away from you or not away from you, like perpendicular, so like this one, it turns it into white, and anything that is facing you completely is 0. And as we go like this, it is going to use like different values. So 1 to 0 like this. And this creates a rim light effect, like fake rim light effect. And you could see no matter which direction I look, it is going to create this rim light. And again, that is, I think that is more than enough for this Fresnel node to explain. But again, you could use the power node to what you call to add some contrast and create this edge glows. I've used it in every single way. I suggest watching these orb videos which explain how the Fresnel works and what we can use it in much more details. But I think this is like more than enough for to understand right now. It's just 0 to 1 value. Okay, this is 1, this is 0. That's all you need to know. It goes in center. Bump offset is also common for parallax effect. It's fake parallax. There's also a node called parallax occlusion mapping, but I think this is like way too expensive. And this one would require like a whole new video, and there are already good videos on it by other creators. But bump offset actually requires a texture, which I'll use this guy again. I'll connect it into the UVs, and it requires a height, which is a scalar parameter like this. As soon as I add it in here, let's do plane. You see nothing's different. But as soon as I do 10, it is closer to us. Right now, this texture is closer to us and there is a parallax effect. But if I do negative 10, the texture is inside now. You could see it is behind. Basically, it is 10 centimeter. I don't know what units this is, but that's how much further it is from you, like this, and it creates a parallax effect. You would go in here and say that clamp, so the texture should not be repeating like this. To avoid this stuff, you kinda have to make the texture not be from edge to edge, I believe. Like there should nothing be touching at the edge. You could see it is not touching anything in here, so it looks black, but because it's touching, it is stretching when you use like clamp. But you could see it is actually behind, and this is good when you want to create some sort of ice, like bubbles that are stuck inside ice, and you could like put another texture in here. So if you use another texture, so cloud texture, if I do R, it's not going to show much difference because it's 0 to 1, and 0 to 1 height is obviously not much. So what we will do is we will multiply this. Or actually you could also do one more stuff. You could just change this height ratio input to 0.1. Let's do 1. And it works, but I think multiplication, let's do multiplication. And let's do negative 10. You'd see we get some wacky effect. And obviously you should know by now that because it's a texture, this texture is getting applied on this area, but because we are multiplying by negative 10, each pixel is getting multiplied by negative 10. Wherever there is 0, obviously no changes, but wherever there is white, it's going to show like this inside, and it can create a nice ice effect. Like if you want to add some bubbles inside, if you want to, you could see it already looks like this stuff is stuck inside and creates this nice wacky effect. So this is good for fake parallax effect. So right now I will explain the sine, cosine and dot. So this is something that I haven't really used that much, which is why I kept it at the end, because I am also a bit not familiar with it. So if we take a sine like this, it is nothing but it goes from 0 to 1 to negative 1 to 1, negative 1 like this, and it keeps going up, down, up, down, up, down like this. So right now it is said that the period is 1. So if I connect it to emissive, it's not going to show anything, because if I do 0, so again, if I do 0 in here, we are at 0, so it's going to look black. And again, keep this in mind. I don't know if there is a good image. So this is what I can show. Okay, so there it is. So you could say this is y equal to sine x. So this is basically starting from 0, going to 1, going to negative 1. So this is where our period starts, like 2 pi. So I'm pretty much sure it is this much is our first period, okay, till 2 pi. And you could see we have set it that it will only last for 1 period. You could see. So at 0, we are at 0. So let's try with, I don't know what value would be around here. If this is 0, if this is 1, then 0.5 would also be 0. So let's try with 0.5 and we get 0. If I do 0.1, 0.2, 0.3, 0.4, you could see it kept going up and then it's going to go down again. So it went like this, then it went down till 0.5. Then if I keep going forward, it's just going to be negative value. So if I keep adding 0.6, 0.7, it's just going to look 0. So it's just going to look black. You could see 0.7, 0.8 and 0.9. So all of it just looks black until we go to 1.1, 1.2 and all that stuff. So what this period means is that a period lasts around this much area, like 1. Imagine this is 1, okay? So 2 pi is basically how much a sine period lasts, I believe. Again, I'm not really good with this stuff, but just keep that in mind, that a period lasts till 2 pi as of now when we type 1. So what would happen if I add a time node in here? It is going way too, it is going from 0, it starts from 0, it goes to 1, then it goes to 0 to negative 1, okay? So it goes to white, then it goes down, but then for this much area, it's just looking black. So that's not really good, because it's good if we keep it 0 and then the graph goes like this. And this is good for like flashing lights or, bouncing effect and all that crazy stuff that requires, periodic stuff like bouncing, jumping and all that stuff, which some kind of like animation that you want to, if you want to create a material which basically moves feathers of like what you call like the wings of a bird, you could also use Sine node. Again, with material offset, you can actually control, the vertices and all. So with this one, you could actually make a butterfly flap its wings and all that stuff. But in materials, what you would do is you want to be at 0 and 1, right? We don't want it to be negative 1. So how we can remap it? So there is actually a node called Sine remap that you could use it. If you double click on it, you could see it uses constant bias scale, which is nothing but it is doing addition of 1 and dividing it by 2. So what this is basically doing is, and this is what I do instead of using this node, is we add 1. So we add 1 and I'll explain the math behind it, and then we divide it by 2. And this basically turns it to 0 to 1. Instead of negative 1 to 1, it turns it into 0 to 1. And how is that though? So I can show it quickly in here, which would be easy. So what happens is when we add 1, it turns to 1 because we added 1. Then this turns to 2. 1 minus 1 is 0. This turns to 2 and this one turns to 0. Okay, because we did addition of 1. And then when we do divide by 2, this turns to 0.5. This turns to 1. This turns to 0. This turns to 1. This turns to 0. So we do start at 0.5. Okay, so that is one issue that you would find, but it's totally okay because now we are getting 0 to 1 after this one. So it starts at 0.5, but we basically get at this like 0 to 1 values instead of negative 1 to 1. Another option is cosine, and the difference between cosine and sine is that cosine starts at 1. So instead of it starting at 0, it starts at 1. And if we do the same thing with cosine, like this, it will turn to 2, negative 2, 0, 2, 0, and it will go to 1, 0, 1, 0 like that. So this is better using cosine because it doesn't start with 0.5, but again really comes down to your preference. And you get this effect. You could see, pretty cool. This is constant bias, I believe. Constant bias. So constant bias scale, you could also use directly this one too. And by default it is 1.5, which is same as adding 1 and then divided by 2, because 0.5 is nothing but 1 by 2. And this is what we get. And sine and all, it's used quite often to create like repetitive or periodic animations, blinking lights or lamppost, or you want to show a car which is basically blinking and all that stuff. One more thing I forgot to show you guys is, let's say if I take, let's say I take a linear gradient, U channel, and then add it in here, and you could kind of see the thing, right? So if I show you sine, you can see that it is this much, right? So it is going from 0 to 1. So 0 to 1. So you could see 0 to 1, then it goes back to 0. It goes to back to 0, and then it's negative to 1. You could see it's negative to 1 like this. So if I do this one after this, and you could see that this is what we get. It starts with 0.5, goes to 1, goes to 0, and then it looks weird, but if you use cosine, it is better like this for this type of effects, because now it's starting from 1, then it's going to 0, then going back to 1, and then in here we have periods, right? So if you do 2, it's going to just look like this, and the reason for that is basically we are saying is that right now this is 1 period, right? But right now we are saying that it takes, how much would it be? Yeah, till here. So it takes like this much, like this. So it goes to like this much, 2 to 4, like this, 1 rotation. So this 1 rotation like this, 1 wave right now is taking 1 period, but if you do 2, it's just going to go like this. Okay, so instead of this, it will basically go like this way. If I can draw properly, like this, because right now we are seeing, okay, just keep that in mind. Imagine this is like a good waves, okay? So it will take 2 period like this instead of 1. But this could also mean that if you turn this to 0.5, it is now going to take half of it. So every half times it is going to repeat these waves. If you do 0.1, you get this patterns. You could see 0.2. Same with this one, 0.2, add it in here, you get this effect. Okay, so this basically controls how quickly the this waves go up and down. Okay, so when you use by default, it is 2 pi like this, but if you decrease it, then it would basically turn into like this waves. So if you reduce it to 0.2, then it is going a lot more quicker in this one direction. Next is dot product, and dot product is basically calculation of two vectors, or not calculation, comparison of two vectors. So when two vectors are parallel to each other, we get 1. When they are perpendicular to each other, we get 0. And when they are opposite to each other, we get -1, like this. So why is this used, and where is this used? Well, when you want to get like the top area of some kind of mesh. So for example, if I take this sphere, and if I take 3 constant, and if I do 0, 0, 1, which is up, okay, so a vector which is like a normalized vector is only going to give you in like 0 and 1. It's going to be in between 0 to 1. So you could see 0, 0, 1, and a normalized vector basically gives you a direction, like which direction it is facing. So when you do 0, 0, 1, it is saying that I have a vector which is facing up. So like this vector, I have a vector which is facing up, like this direction. You could see, as long as you are in global, it will always be facing up like this. And then we have this vertex normal, which are facing in different direction, and these are all giving you 3 floats, because there are 3 values like x, y, and z, but these are all between like 0 to 1s. So for example, the top one, which is this one, would be 0, 0, 1, and this one, which is facing here, you could see y, it is facing y, so it would be 0, 1, 0. But then this one would be like different decimal points. So if I say that compare the vertex normals, which are like this vertex normals, with 0, 0, 1, so are they facing up or down? And if I do this, we get this mask where whenever it is facing 0, whenever this vertex normal is facing 0, 0, 1, we get white. Okay, whenever this starts facing completely perpendicular, we get 0. So we are comparing both of them, right? We are comparing it with this one, 0, 0, 1, we get 0. And when this vertex normal is opposite of this one, we get -1. So this is -1. You could obviously add a saturate to saturate node to basically turn everything to 0 to 1. So this one would turn to 0 after you use saturate, because -1 would turn to 0. And this way we get like the upper area. So if you want to use a different texture on top and different texture at bottom, if you want to use snow or some kind of stuff that only applies up, like moss and stuff, then you use this type of method, and it will work on any type of any type of mesh, as long as unless you manually change the vertex normals. And you would see this actually been applied on my autoclave materials. So where is it? Like this easy autoclave slope materials, you would see this where I apply this green texture on top and side texture as this like this ground ones. And when we do 0, 0, 1, we are basically comparing each vertex with this top. Okay, so whenever this is the top one, we get 1. Whenever it's side one, we get this one. And when we do downwards, we get -1, like this. So that is dot product. This is all for this video. I hope this helped you. You can support me via my Patreon, where I release some of my stuff. It also helps me run my website and all, and like this website where I have my textures and videos added in here, and all the materials and stuff, free textures. Check my Patreon. And yeah, thanks for watching. I hope this helped. I made this video because I didn't have a video like this when I started making or learning Unreal Engine, but I hope this helps. And yeah, keep making. Goodbye.